Hello, I'm Julie Lerman.
And this is Steve Smith.
In this module of Domain-Driven Design Fundamentals, you'll learn about repositories, another critical pattern for domain-driven design.
We'll start by defining what repositories are, and then we'll provide some tips for working with them, as well as talking about some of their benefits. There are different ways to define repositories and plenty of debate around their use. We'll address some of these points.
Next, we'll introduce you to the specification pattern and how it can be really helpful when you're implementing repositories. Then we'll open up Visual Studio again and show you how we've implemented some repositories in the scheduling app.
Now, Julie, if this were an in-person class, I'd definitely ask for a show of hands. Who has heard of the repository design pattern? I would expect most hands to go up.
I hope so too. I think the repository pattern is by far the most popular element of DDD to be practiced outside of domain-driven design. They can be valuable in so many applications as a way to simplify data access and enforce separation of concerns. When I began learning about repositories and implementing them in my own software design, it had a huge impact on my application architecture. Along with automated testing practices, it really forced me to consider separation of concerns with each method and behavior I added to my software.
Personally, I love the pattern, and I find it makes it much easier for me to write good, testable code. We're going to talk about using repositories within a DDD application, but if you want to learn more about the pattern itself, you can look in the Design Patterns library. And I know Julie also discusses using them with Entity Framework in her Entity Framework in the Enterprise course.
You can see that repositories are part of the DDD mind map as they're used to access entities and aggregates. Any system that needs to persist between restarts has some kind of persistent storage for the state of the system, like a database. Many applications focus a great deal of effort on the mechanics of querying, fetching, and translating data to and from objects, to the point where it distracts from the model that these objects are meant to represent. And having ad hoc access to the data source also promotes having developers query for any bit of data they want, anytime they want, rather than using aggregates. This makes it pretty difficult to manage the consistency of aggregates by enforcing their invariance. At best, the logic for enforcing the integrity of the model becomes scattered among many queries, and at worst, it's not done at all.
Applying model-first design and separation of concerns means pushing persistence behavior into its own set of abstractions, which we refer to as repositories. Only certain objects, like specifically aggregate roots, should be available via global requests. Repositories provide this access, and through omission, prevent access to non-aggregate objects, except through their aggregate roots. They give you the ability to constrain the data access so you avoid lots of random data access code throughout your application.
When you think about the life cycle of an object in your application, you should consider two cases. In the first case, you have objects that are not persisted. These objects are created, perform some work, and then they're destroyed. In the second case, you have objects that are persisted. These objects have a slightly more involved life cycle, since after the object is created, it must be reconstituted with whatever state it had when it was last saved. Then it can perform whatever work the application needs it to do, after which it may need to save its state to some persistent storage before finally being destroyed. You can use repositories to manage the life cycle of your persistent objects without the objects having to know anything about their persistence. We call these objects persistence ignorant because they're ignorant of how they're stored into and retrieved from a data store.
In his book Domain-Driven Design, Eric Evans speaks quite a bit about repositories. They can be summed up by saying that a repository represents all objects of a certain type as a conceptual set, like a collection with more elaborate querying capability. Repositories can add a number of benefits to our application. First of all, they provide a common abstraction for all of our persistence concerns, which provides a means for clients to very simply obtain model objects and to manage their lifecycle. They also promote separation of concerns. The domain logic and the user interface can both vary independently from the data and the backend data source that is used by the application.
The public interface of a repository very clearly communicates our design decisions. Only certain objects should be accessed directly, so repositories provide and control this access. Another important benefit is that repositories make it easier to test our code. They reduce tight coupling to external resources like database, which would normally make unit testing difficult. Having repositories separate from client code and domain logic means that we can easily make improvements to optimize data access for this application. Tuning for performance, adding caching behavior, etc. is all much easier and safer when the code for data access is all encapsulated in one or more well-known classes. All of this makes your code easier to maintain. Here's some basic guidance you should keep in mind when designing repositories. First, a repository should have the illusion of a collection of a specific type of object. You'll be adding the objects to the collection, removing them, and retrieving objects from the collection. But that it is an illusion of a collection is important to keep in mind. When you interact with a repository, these are the types of methods you'll be calling: add, remove, and retrieve. Your calling code doesn't care how the repository performs those actions. So in the repository, you might have code that responds to a retrieve method, goes out to a database and gets data. But it could be getting data that's already in memory, or it might be grabbing data from a text file in your computer.
Another important recommendation for repositories is to set up access through a well-known global interface. That way, developers that need to interact with the repository will be familiar with a common pattern for using it.
Here's a simple repository interface example. Depending on the size and complexity of your software, you may have a few layers of interfaces.
For example, if you anticipate having a number of repositories for a schedule aggregate used in different bounded contexts, you might want an iSchedule repository interface that not only implements the lower-level interface, but defines some other methods or properties that every schedule repository is required to have, regardless of the bounded context it might reside in. Because a repository acts like a collection, you'll want methods to add and remove objects to encapsulate the underlying data insertion and deletion operations. We've got these defined in our iRepository. It is up to each concrete implementation to define how add and remove will actually work.
It's not unusual to need to add specific query methods to individual repositories. Whether you need a custom subset of entities or a specific way to load entities' relationships, custom methods are a simple way to achieve this. For example, if we wanted to fetch a schedule instance with all the appointments for a given day, we could add a method to the schedule repository that might have an EF core implementation like this one.
Likewise, if we just wanted to be able to fetch a client with their patients, we could add a method like this one, which will eager load the patients when it loads the client. Be careful with this approach though, as it can grow out of hand and your repositories may end up with many different query methods. A simple way to address this is to use specifications instead, which we'll cover later in this module.
In addition to these specific tips for implementing repositories, you should also keep in mind these more overarching tips. First, be sure to provide repositories only for aggregate routes that require direct access. And next, keep the clients focused on the model, while delegating all of the object storage and access concerns to the repositories.
We're not always going to land on the happy path, so we do want to share with you some common problems that you might run into, how to recognize them, and most importantly, how to avoid them.
Remember, your client code can be ignorant of the implementation of your repositories.
But developers cannot.
It's important that developers understand how your specific repository is implemented. Otherwise, they can run into a number of different problems.
So we're talking about not just the developers who are implementing the repository, but also the developers who are using the repository.
One of the common repository problems that developers working with repositories often encounter is called an n+1 query error. This is where in order to display a list of rows from the database, you end up calling one query to get the list, and then a number of queries equal to the count of that list to fetch each item individually.
Another one that I see a lot is when people are fetching related data. With Entity Framework, they're either using eager loading or lazy loading. And especially with lazy loading, there's a lot of developers who don't really know what to expect from it. And just because it's easy and it just works, they use it and then run into all kinds of problems because of it.
And depending on how your data is structured, sometimes if you're trying to fetch just one or two properties that are represented in a particular column in a data table, you might end up fetching more data than required if you pull back the entire row, which might include dozens of columns and a lot of actual data there. These are things that knowing how your underlying data is persisted and how your repository is implemented, how those things work, can make a huge difference in your application.
Most of these blunders impact how data is accessed in a data store. And that means that one of the best tools you have for surfacing these problems is profiling your data store. Many of the IDEs we use for managing databases have profilers built in. Some examples are SQL Server Profiler, JetBrains Data Grip, and Azure Data Studio. Many of the APIs we use also have logging capabilities that can relay database activity. As a .NET developer, I often use the .NET Core Logging API or some of the features built into Entity Framework Core. But most any language you use can do this, and all of the cloud providers have ways to trace activity in their various data stores. There are even third-party tools dedicated to database profiling. The suite of profilers from Hibernating Rhinos is a great example. They have profilers for RavenDB, Azure Cosmos DB, and the EF Core and NHibernate ORMs.